Okay, so we're going to pick up where we left 6.2. As soon as we get 6.2 done, I will record 6.3. If I have time, I'll finish out the chapter as well. Okay, so what we're going to work on now is adding and subtracting rational expressions. Remember, rational expressions are in the form of P of X over Q of X, where Q of X cannot equal 0. Okay, that is what a rational expression is. So with most things dealing with fractions, you have to make sure that you have a common LCD. In this case, our LCD is done for us, meaning it is the same, but we do have some stuff that we have to figure out. For instance, for A, it's a little bit nice. You just have to do 5 plus 2. Realize your denominator is the same, so you only have to write it once. 5 plus 2 will give us 7 over 3x, and you're done there. Okay. Now, if it's multiplying, you are allowed to reduce if possible. Now, nothing goes with 7, so you can't reduce the 7 and a 3, but if it would have been a 6 and a 3, you could have reduced that. But you cannot reduce if you have an addition or subtraction, in which case you could only reduce if it is a shared polynomial. So that kind of brings us to part B, where we have to realize again we have the same denominator, so we'll bring the tops together. But what you have to realize here is that this is a difference of squares. Okay, which means you're just going to split the x's, do a plus minus of the root of 9, so that's going to be 3 and 3. And at this point, what you should notice is that the x minus 3's are going to cancel because they're the same binomial on the top and bottom. So this answer here is just x plus 3. Not all of your answers are going to be that nice. Okay. All right, last one is also the same denominator, so we can just go straight to adding our tops together. But again, we want to factor, and I would change the top to be x plus 2, because you're allowed to do that thanks to the associative rule. Okay. You need factors of 2 that are add or subtract to give you 1. It's a nice factor situation, so you just need a positive 2 and a minus 1. Should see then that the x plus 2's will cancel, and you'll be left with 1 on top and x minus 1 on the bottom. Now the 1's cannot cancel because it has a subtraction sign with the binomial on the bottom. Okay. The next set of examples that we're going to work on have, as you can see, different denominators. So the first denominator is 3x, and the second denominator is 4x. So if you list all the denominators out, or all the pieces, it's kind of like you have a 3, a 4, and an x. and the x is shared. So what I would do here to find the LCD is I would take 3 times 4 times x. I would get 12x. Then what I would do, and is I would say, okay, I have to take 3x times 4 to get 12x. So if I'm multiplying the bottom by 4, I have to multiply the top by 4. And then if I'm taking 4 times 3, that means I have to take the 7 times 3. So I'm going to get 8 plus 21 on top and my 12x on the bottom. So that's 29 over 12x. I can't reduce, so that's my answer. Now, let's look at the bottom one. So our denominator pieces are z and z minus 5. Well, before we just multiplied our pieces together because we didn't have any that matched up. So we don't have any that match up here either. So we're going to multiply them again. Z and z minus 5. So you can leave it like that if it helps you, or the other way it would look is if you distributed it, so it'd be z squared minus 5z. Okay. Because of our situation here, I would think leaving it this way for what we're doing will be best. So here we have 3 over z, and what we're missing is the z minus 5. So if I multiply the bottom by z minus 5, I have to multiply the top by z minus 5. Now, for the next one, we're missing a z. So if we multiply it on the bottom, we have to also multiply it on the top. So then you just have to distribute. So on the top, we get 3z minus 15 minus 6z, z minus 5 on the bottom. If we combine our like terms, we get negative 3z minus 15, and again, z minus 5. We can pull out a negative 3. So we have z plus 5 and z minus 5. But it's important that you pull out the negative 3 because if we could have reduced, then we would have reduced. Okay. So you can see though, we can't reduce even if we tried. Even if we pulled out just a negative here or just positive here, we would still have a negative z minus 5. Okay, so that's that one. All right, next one is a little bit nicer for A because it gives us a nice common denominator. So all we're going to have to do is combine like terms. Remember, when you have this negative here, it goes to both or the whole entirety of the second fraction. You only have to write the denominator once because it's already common. So we'll distribute this negative, and we're going to end up with 18x plus 7 minus 2x plus 13. 18x minus 2x and then 7 plus 13. That'll give us a 16x plus 20. And you can pull out a GCF on top equal to 4. So we'll pull out a 4 and have 4x plus 5 left inside. You'll be able to see that those will cancel. So your answer for A is just 4. Okay. Now B is a little different. B, you have to find your LCD. So denominators are x minus 3 and x plus 3. You don't have anything else, so those actually are your least common denominator. Okay, so then we have to figure out what's missing. So for the first one, we have 5 over x minus 3. Well, you can see that the x plus 3 is what's missing. So we added, or we multiplied into the bottom, so then we also have to multiply it into the top. Okay, for the second one, it's x minus 3. Okay, and what we have to do now is rewrite it, realizing that you have the same denominator. We're going to distribute and then combine our like terms. Remember that negative is going to the second piece. So we'll have 5x plus 15. We'll have negative 5x plus 15 all over the denominator. So in this case, the 15s here actually cancel out. So actually, nope, sorry. The 15s do not cancel. It's the x's that cancel. Apologies. So your answer here is 30. 15 and 15 give us 30. Oh, I can't write that to save my soul today. 3, 0. X minus 3, x plus 3. Okay, and that's it for that one. Again, my recommendation for these is to pause the video as you work through them, try to answer them without me, and then see if you're doing it correctly. Okay. So for this one, we have to figure out our LCD. And what's good to know is that these are basically the same. Here's the small difference. T minus 9 compared to, actually, let's move that up to here, versus 9 minus t. 9 minus t is just a -1 brought out. Okay, so these are the same, it's just one has a -9 in the front. Okay, so we can use the LCD as either. We can have method 1, with the LCD equal to t minus 9. Okay, so if you do that, then the first fraction stays the same. And then the second fraction, you just have to realize that you needed to multiply by a -1. So we do -1 here. And then what we'll do is we'll replace the 9 minus t with the t minus 9. That's what happens there. That's the difference. So then we end up with t minus 9 or minus 2, sorry. And t minus 9 on the bottom. And that is your answer. Okay, that's one option. Second option is to leave the LCD as 9 minus t. So if we do that, then we have to realize that we need to multiply the first fraction by the negative and rewrite that denominator. So then you would end up with -t plus 2 over 9 minus t. Either are correct. Okay. They're exactly the same, basically. It's just one you have from the negative standpoint and one you have from the positive standpoint. That's the only difference. So here we're actually mixing, adding, and subtracting as, you know, as the question asks. So what we have to do first is figure out your denominators. And to help you out, this part would be y minus 3. So your denominators in general are y minus 3 and y minus 3. So if you notice, this denominator and this denominator are represented within that denominator. So your least common denominator is just going to be the combination of y minus 3. So when you come back over here, you'll have 6 and y on the bottom. So then you have to figure out what's missing. Well, that's this piece. So y minus 3 on the bottom means we have to do y minus 3 on the top. Then we have a minus. We have a 1. We have y minus 3 on the bottom. So now we're missing the y. We're going to multiply it on the top and the bottom. Now, the last one, you'll notice has the whole piece. So we actually don't have to do anything else with it. What we are going to do is distribute and combine like terms. So we'll have 6y minus 18 minus y plus 3 all over the denominator of y minus 3. Bring the 6y and the y together, the negative 18 and the positive 3. So you end up with 5y minus 15 over y minus 3. This shows you exactly why you need to factor. So we can pull a GCF out here. GCF equal to 5. So 5y minus 3, y minus 3. You should see here that the y minus 3's cancel. So your final answer here is 5 over y. Okay. All right. Almost done with this lesson. Okay. We need to find the LCD first. So in order to find that, we have to figure out our denominators. But the way they're represented right now don't really help us. We have t squared minus 2t minus 8. And we have t squared plus 3t plus 2. So let's factor those first. So we're going to need the t's split, and we need factors of 8. That'll give us a difference 2. Okay, so that'll be 2 and 4. We need a minus 2 and a minus 4 and a plus 2. So plus 4. Dang it, I keep saying it backwards. Plus 2 and a minus 4. Now for the next one, we need factors of 2 that'll add or subtract to give us 3. Well, we know that's just going to be 1 and 2. So we're going to need a plus 2 and a plus 1. Okay, so remember, when we're finding our least common denominator, you want each piece represented one time, and you have to be careful because sometimes you might have the piece listed more than twice. If it's listed more than twice, you have to list it a second time. So it's like they're done in pairings. Okay, so here the t plus 2's we have only twice, so we only need it once. T plus 1 and t minus 4. That's our whole LCD. So let's rewrite this as what we're given here. Okay, so we know each piece is going to need part of the new LCD. So the new LCD, or the LCD, is 2t, t plus 2, t minus 4, t plus 1. That's what the new one is. Okay, so For the first piece, you had a t plus 2 and a t minus 4. So the part that's missing is the t plus 1. So we'll do t minus 1 and t plus 1. For the second one, and I'll color code this for you guys if you need it. So the second one, you had t plus 2, t plus 1, so you need t minus 4. So we'll do 2t plus 3 times t minus 4. Okay. If you're not understanding where I'm getting that stuff from, you need to ask during the review. Okay, so the next piece we have to do is we have to figure out our foiling. So I'm going to do that over here. Do t plus 1 and t minus 1. So that's t squared plus t minus t minus 1. The t's in the middle actually cancel, so you're left with t squared minus 1. And then we'll do the other one, 2t plus 3 times t minus 4. We end up with 2t squared plus 3t minus 6t minus 12. So that becomes oh, that's actually an 8t minus 8t. So these combine to give us 2t squared minus 5t minus 12. So now we're going to bring those back. You get t squared minus 1 minus 2t squared minus 5t minus 12 with the LCD. Then we just distribute the sign. And we'll have to simplify. So t squared minus 1 plus, minus 2t squared plus 5t plus 12 over t plus 2, t minus 4, t plus 1. We want to bring the t squareds and the minus 1 plus 12 together. So your answer is going to be minus t squared plus 5t plus 11 over t plus 2, t minus 4, t plus 1. The order of your trinomials on the bottom do not matter. They just all have to be there. And typically for the numerator, it's in descending order for the power of the variable. Okay. Last problem in this lesson, and then I'll move on to section 2.3. Or sorry, 6.3. All right, so first things first, let's do our denominator factoring. So right now we have m squared minus 6m plus 9 and m squared plus m minus 12. That's going to become the m split. You need factors of 9 that'll add or subtract to give you 6. So that'll be a minus 3 and a minus 3. And you need factors of 12 that'll give you a 1 in the middle. So that's a +4 and a -3. Here's what I was talking about before when I said that you need to be careful if there's an extra term that's the same. You need to list it twice then. Stop it. So here and here, those go together. You only list it once. But here is a second term. So m-3 again. And here is a third term. Okay, so you need all of those. All right, so let's rewrite this given what we know. 2 over m-3 m-3. I'm getting this from right here. Okay, so +4 over m +4 m-3. So now I want to figure out what I have missing. Okay, so in the first one, what we're missing is the m +4. So I have 2, and then m +4 on the top. And the bottom. And then for the next one, I'm missing a second m-3. Okay, so now that I have those, I can start distributing and bringing it together. So I'm gonna have 2m + 8 + 4m - 12 all over the LCD. Again, it doesn't matter the order as long as you have it all represented. 2m, 4m, 8, -12. It's going to give me 6m -4 over m - 3 squared m + 4. Now I can square that because there's 2 of these here. And I can tell you, even if you wanted to pull out the 2, that's the GCF. It's not going to make a huge difference here. But for the sake of making sure that we always factor when we can, we'll pull out a 2. We'll have 3m - 2 left on top. And then m - 3 squared m + 4. Okay. I will accept either of these. I will even accept it with the bottom being like this. Okay, doesn't matter. I'll accept all 3 of those. Again, the reason why we can square it is because there are 2 of these. So that leads to this. Okay, this will be uploaded shortly and I will get going on 6.3. Thanks, everybody.